Okay. We're going to now look at classifying some ODEs as either linear, nonlinear, separable, or non-separable. So I've got 10 of these ODEs, are just random examples I wrote down. They're all first order equations in y and x. Obviously, your letters may vary. And we're just going to go through and classify what these things are and why. The first thing that I look for is powers of the dependent variables. This is dependent. That's a power of a dependent variable or a function of a dependent variable. So this thing is not linear, non-linear. Right, immediately. Now we ask if it is separable. Separable means that we can write the right-hand side as this. Oops, that should be a y. Right. That's the question for separable. That means we've got to put this on the other side, and we're actually dealing with y prime. I'm just going to write what prime notate, x squared minus y squared. That cannot be written as a product of a function of x and a function of y, and this thing is non-separable. So where am I going to write that? Not separable. All right. So we've disposed of that one. Back now onto the second example. Again, we've got a y squared. So this is nonlinear. However, now we've got a product of y and x. So we can actually write this as, this is a separable equation. We can write f of x equals x squared, g of y equals y squared. So that's a separable equation, and we can solve that with the usual techniques. This one's interesting. Number 3, it is linear because it's just the y doesn't have, there's no function of y, and there's no function of dy dx. That's something else we've got to check. We haven't had to check this in the past because it's always failed on function of y. But this equation is linear, and it's also separable because the right-hand side can be written as a product of two functions. So this is linear. And it's separable. All right, number 4, there's no function of y. There is a function multiplying y, but that function is a function of x alone, so that's cool. We've got dy dx all by itself. We've got another function of x. This is a linear equation in canonical form. It's also not separable because if you move this over, you'd have sine x plus cos x. Sine x, y, and you'd have a cos x term. There's no way you can write that as a product of two functions. So that's not separable. Just for completeness. This one here looks very similar. Number 5 looks very similar to the previous example, except we've now got sine y x instead of sine x y. This makes the equation nonlinear. And if we put this over there, there's no way we can disentangle the y's and x's. So this is neither linear nor separable. So that's a bit of a bummer. This one, this looks linear because there's a y all by itself. The dy dx, it's got an x associated with it. But no function of y and dy. So number 6 is linear. However, if we move this across, if we put everything on the right-hand side, we're not going to be able to disentangle x and y, so this is not separable. Sorry. Number 7, we've got a function of y. Can we get rid of it? Yeah, we could divide through by y to try and get rid of it, but then we'd have an x divided by y. It's going to be nonlinear, right? And that assumes special cases y not equal to 0. So this is nonlinear. Is it separable? No, because we've still got this additive x thing. We're not going to be able to move everything onto the right-hand side and rewrite it. This one, it's clearly nonlinear, right? As soon as you see sine y or y dy dx, not linear. Okay. However, we've got a product of x and y. We don't have any additive factors, so this one looks like it could be separable. Indeed, if we move the sign, if we divide by sine y, we can see that one of our functions is going to be y over sine y, and then the other function is going to be cos x. This one is separable. So I'll just write it out in an alternative form. Right, and that's the equation once it's been separated. Good luck doing those integrals. That y on sine y isn't going to be too nice. Number 9, I put it in because it's a bit curious. One might think it's obviously nonlinear, right? You've got a sine of y something, right? So this is nonlinear. You might think that a trig identity will save you and make this separable, but the additive trig identities gives you things like sine x, sine y, cos x, cos y, or sine cos, whichever those trig identities happen to be. Either way, you're not going to get a disentangle. This thing does not disentangle. Even if you look at trig identities, so non-sep. Right, our last one, it's a product of two functions, but you'll note that you can do that. It's non-linear, you've got a y cubed. And there's no way you can rewrite that as, you can't, there's no common factor of x squared that you can pull out and make this separable, so this is not separable. All right, so that's a few examples of separable and non-separable and linear and nonlinear equations.